Example 2, making predictions. You can use an equation of a linear relationship to predict a value between data points that you already know.
You know, lines are everywhere. And okay, sure, there's lines when you're waiting to get into the movies or waiting for you to get on the bus. But you know what's really interesting? Actually, while you're riding the bus, there are mathematical lines all around us. They're often invisible, and the great thing about thinking about math together is that we can make those invisible lines visible. So let's check out a really fun challenge that involves lines on a bus, but not the kind that you wait for, the kind that you enjoy. Let's check it out together. So this graph right here represents the cost for bus rides of different distances. And here's our challenge. Let's see if we can predict the cost of a bus ride that covers a distance of 5.5 miles, or 5.5 miles. So let's take a look at the graph together. So first of all, notice that on the x-axis we have the distance traveled in miles, and then on the y-axis we have the cost in dollars. And some of the points you can see are labeled. For example, right here we see that for a distance of 4 miles, we see that we are right in between these two marks. And what are those marks? Well, they seem to be the even numbers. 2, 4, 6, 8, 10, 12. So it's the number right between 10 and 12. So that point actually is 11. So what we see actually is that the coordinates of that point are 4, 11. And just for fun, let's take a look at this point way up there. That happens at a distance of 8 miles. And again, we're right in between these two values, which is 18 and 20, which means that that y value is 19. So we also have an ordered pair 8, comma, right between 18 and 20, which is 19. Okay, great. So you can see there's lots of points on here, but we're interested in the cost for 5.5 miles. Now that's actually a little bit harder to do. Can you see that? Well, here's 4 and here's 6. So 5 is right in between, and so 5.5 is in between the in-between and 6. So it's kind of really hard. Now you can try with a straight edge to see if you can read it off. It kind of looks to me like it would be right here, which would be right this point, which would be 14. So my guess is 14. But it's hard to know just from this picture, as accurate as the picture is, because you have to kind of read it, and you might be off a little bit. Turns out that's why it's great to write equations for lines, because then we can see exactly right. So, in fact, let's take that on. Let's find the equation of this line. Now, you know how lines look. They are y equals mx plus b, where m represents the slope of the line, and b represents the y-intercept, somewhere down here. Well, finding the slope is actually easy if we know 2 points. Well, we've already found 2 points, so this is actually going to be really fun, because I can find the slope by just looking at the change in the y's divided by the change in the x's. So the change in the y's, I'll write that as 19 minus 11, this y minus that y, divided by, now I have to go back and use the same ordered pair I started with. I started with the 19, so now I'm going to start with the 8 minus the corresponding x value, which is the 4. So, what does this equal? Well, 19 minus 11 is 8, and 8 minus 4 is 4, and so that just equals 2. So we see this as a slope of 2. The slope, by the way, is a positive number, so notice the line should be going up, and it is, so that actually confirms it in my mind. And so now where we are is we see the equation of the line so far. It's like a work in progress. You have to kind of work your way up to the whole thing. We've got y equals slope, which is 2x plus b. So we're almost there. All we have to do is find b. That's the y-intercept. And again, you can try to read it off the graph. It looks like it's a little bit bigger than 2, doesn't it? But it's not exactly clear whether it's like 2.5 or 3 or 3.5. Who knows? So let's be more precise and plug in one of these points for the x and y. Remember, this is an x value. I could put it in here. This is a y value that corresponds. I can put it in here. And by doing that, that should give me an equality, and I can solve for b. So let's try that. Let's write this as 11 equals 2 times 4 plus b. Check it out. There's the x value I plugged in, and the corresponding y value I plugged in here, and that now is an equation that should hold, and let me figure out what b is. So this is actually easy, isn't it? Because it's 11 equals 2 times 4 is 8 plus b. If I subtract 8 from both sides, then I see that, in fact, b is 3, which was kind of one of our guesses, in fact. That value is actually 3. So now we see that b equals 3. I can write the equation of the line and write it as y equals, I'm going to actually make a mistake here just for fun. So let's see if you can find the mistake. Y equals 3x plus 2. Now, do you see why that's wrong? Yeah, we did all this great work in finding the 2 and finding the 3, but we put them in the wrong spot. This is the slope, and this is the y-intercept. So we have to undo all of that stuff and get us back to here and write the slope, which we saw was 2, that's correct, x plus 3. I think you can learn a lot from making mistakes sometimes. So this right here represents the equation of the line that's given by this. And now we can actually answer the question. What's the cost of 5.5 miles? Well, all we have to do is plug in 5.5 for x, and what would we see? Well, we'll see that y, let me make some space here. I want to make a little space because you know what? I don't want you to get all crowded in. Let's just get rid of all this stuff. Say goodbye. Goodbye. Okay, and now we have plenty of room to write the following. I can write y equals 2 times 5.5 plus 3. And so what does that equal? Well, 5.5 times 2 is 11, plus 3 is 14. And so what is 14? Well, that represents the dollars. So it's going to cost $14, and that is our answer. It's going to cost $14 to travel 5.5 miles on this bus. So, looking at lines allows us to see everything more clearly. And so next time you're on a line and it's bothering you, think, wait a minute, lines are also our friend. Say it with me, lines are our friend. I'll see you soon. Okay.